Good morning. Hopefully you got on okay with those last questions from question 5, the linked quadratic equations by substitution. Definitely a complicated bit of algebra, so do let me know if there's any part of that that's still confusing you. We're going to move on with the notes today, and we're going to do page 30. Now we're still working on quadratic equations, even though this doesn't really look like a quadratic equation. We have an unknown, a variable y, and we have fractions, but this time it's not like the fractions we're used to seeing. The denominator has a variable in it. And when the denominator has a variable in it, we're still going to multiply across by a common denominator, but let's make a couple of notes on what those common denominators might be. So the common denominator will usually be all the denominators multiplied together. So that means in this case, my common denominator is going to be y plus 2 by y plus 3 and by 5. This is the low partial credit step for our question, by the way. Even just writing down, identifying the common denominator will get you low partial credit in questions like these. So those three terms have to be multiplied together. Now, if I had something that one of those divided into, I would probably change up my common denominator, but you can always do this. Just remember that you might have to simplify at the end if you find your common denominator by all denominators multiplied together. If you have more than one term with a variable in it, with y in it, then you'll end up with y times y somewhere in your answer, which means you end up with a quadratic. So if you have more than one term with x or y or whatever variable it is on the bottom, getting rid of the fractions and simplifying and bringing everything to one side will lead you to have a quadratic equation. So I did say before Christmas that we would be looking at equations where there was variables on the bottom. We hadn't really done much with these. Okay, the technique is the same as when we do quadratic equations with numbers on the bottom. We multiply every term by our common denominator. So let's take a look at what that looks like. My common denominator is y plus 2 by y plus 3 by 5, and I'm multiplying each term in turn. So I'm multiplying 8 over y plus 2 is going to be multiplied by that, minus y plus 2 by y plus 3 by 5. We'll start to do this really quickly. It looks a bit time consuming right now. By 2 over y plus 3 equals, and you can do your multiplication either side of it, y plus 2 by y plus 3 by 5 by 8 over 5. Okay, so that's exactly the same as what I have written up here. I've just written it down here, but each term is multiplied by my common denominator. And what happens? Well, in the first term, the y plus 2 cancels with the y plus 2. In the second term, the y plus 3 cancels with the y plus 3. And in the third one, all that cancels is the 5. So when I write this down again, all my fractions are gone, but I have something new in every term. So on the first one here, now I'd normally do some of the multiplication in this step, but because it's the first time, I'm just going to write it down. We're going to have 5 by 8 by y plus 3. Why did I rearrange it like that? Because it's easier to have the numbers in front of the brackets, and multiplication is commutative, so it doesn't matter what order I put them in. Here, I'm going to put the numbers in front. I'm going to have 5 by 2 by y plus 2 equals 8 by y plus 2 by y plus 3. Okay, so all I've done there is I've written down what was left over after I had done my cancelling. The next step then is to multiply out my brackets, and I might do this in 2 steps. So I've got 40 by y plus 3 minus 10 by y plus 2 equals 8. I'm going to do the brackets first. Y by y squared, plus 2 by y, plus 3 by y, plus 6. And then I continue to multiply out my brackets and simplify. I've got 40y plus 120 minus 10y minus 20 equals 8 by y squared plus 5y plus 6. And just keep going, simplifying here. I've got 40 take 10, 30y, 120 take 20, plus 100 equals 8y squared plus 40y plus 48. And I want to bring everything to one side. I'm actually going to bring everything over to this side so that I don't have to mess around with changing signs. But if you prefer, bring everything to this side and change your signs afterwards. So I have 0 equals 8y squared, 40 take 30, plus 10y, minus 100 plus 48, minus 52. And if it's equal to 0 on that side, it's equal to 0 on that side. So there's my quadratic. And you might notice that 2 goes into everything. So because I can, I will simplify this by dividing across by 2. So I have 4y squared plus 5y minus 26 equal to 0. And I need to solve this. Okay, we can attempt to use the guide number and find factors, but because the numbers are quite big, I think it would actually be more convenient to use our minus b formula. So again, reminding ourselves of the minus b formula. I'll write it to the side over here. Y is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a, where a is the y squared coefficient, b is the y coefficient, and c is the constant. So when I fill in here, I get that y is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to put this part into my calculator in one go. And as we discussed on Friday, you might have to do that in 2 steps, depending on your calculator's settings. So what I get is the square root of 5 squared minus 4 by 4 by a negative 26, and that's 21. I thought it probably would work out evenly, and it does. I got 21 there. So y is minus 5 plus or minus 21 over 8. Work out our plus value, work out our minus value, and we get the 2 values for y. So y is either, let's make this up a small bit, y could be minus 5 plus 21 over 8. Probably do this in your head. Especially in an exam situation, why not use the calculator and make sure we get it right and don't make a mistake. Minus 13 over 4. You can leave it as a top-heavy fraction like that. You could change it to minus 3.25 and you will get full marks. The default in senior cycle maths now is to leave our answers as fractions, never mixed numbers. Okay, so just to go over those steps again from the beginning, we find our common denominator. It is all 3 of the denominators multiplied together, but we don't multiply out the brackets, we just leave them in brackets, and then we put it next to each term because it will cancel the denominator in each case. Then we multiply out our brackets, bring everything to one side, we will get a quadratic equation, and we can solve the quadratic equation. You could have done this with factors. Doesn't matter how you solve it. There's no strict way that you have to do it. Sometimes the minus b formula is easier or quicker, and we get our two values for y. Remember what this means. This means that if I substitute in either of these two values for y up here, I will get 8 over 5 as my answer. So if I subbed in y equals 2, I'd have 8 over 4 minus 2 over 5. 8 over 4 minus 2 over 5 is 2 minus 2/5, which is 1 3/5, and 1 3/5 is 8 over 5. You can use your calculator to check it. A little bit more complicated with the fraction, but we will get the same answer. Okay, moving on then, we're going to look at this word problem that is going to lead to a quadratic equation. See if I can sharpen the focus there. Now, this is the kind of word problem that's going to give us variables under the line. So I'm going to have fractions like the question that I had above, and then I'm going to have to solve those fractions in the same way as I've done here. So let's look at the information. A class planned to make 100 posters. Each pupil was to make the same number of posters. There were X pupils in the class, but on the day that they were to make the posters, 5 pupils were absent, so each pupil had to make 1 extra poster. Calculate the number of students normally in the class. Okay, so let's look at the information that we have here. And just break it down step by step. The class has X pupils, and the number of posters, the number of expected posters, let's call it P. P would have been 100 divided by X. So the 100 posters divided by how many people were in the class. But the actual posters was one more, P plus 1, okay? Because everybody had to make 1 extra poster. And that was 100 divided by 5 fewer pupils. So I have 2 pieces of information there. Now that kind of looks like simultaneous equations, right? What I'd like to do is have them both be P, and then I can set them equal to each other. So that's my first piece of information. This is my second piece of information. Actually, we'll do it like simultaneous equations, because that's what we're used to doing. So this, let's call this equation 1 and this equation 2. And we're going to get rid of P because P is something that we invented, or I invented. P wasn't anywhere in the question. So I'm going to cancel P, and I'll do that by equation 2 take away equation 1. Okay, so what that looks like is equation 2 take away, equation 2 take away equation 1. Equation 2, P plus 1 is equal to 100 over X minus 5, and minus P is equal to minus 100 over X. The P's cancel, and I get 1 is equal to 100 over X minus 5 minus 100 over X. And now I have that equation that I was looking for. Let's write it with the number on the other side. 100 over X minus 5 take away 100 over X is equal to 1. Okay, so we used the information, we wrote down what they told us here, we're writing it in mathematical terms, and then we've got 2 equations, 2 unknowns, cancel one of them to get a single equation in one unknown. Now, this is just like this one up here. So what's my common denominator? What am I going to multiply everything by? My common denominator is going to be x by x minus 5. There's no denominator here, so I have x by x minus 5 times 100 over x minus 5 minus x by x minus 5 by 100 over x equals x by x minus 5 by 1. The denominator cancels with the matching part of the common denominator. The denominator cancels with the matching part of the common denominator. There's nothing to cancel here. And then I write it down so that I can multiply out my brackets. I've got 100 by x minus 100 by x minus 5 equals 1. So we can just drop the 1 because when you multiply by 1 it makes no difference. X by x minus 5. Now let's multiply out the brackets. 100 by x minus 100 by x plus 500 equals x squared minus 5x. Those guys give me 0x, and then everything to one side. 0 is equal to x squared minus 5x minus 500. So that is my quadratic equation. I'm looking for something that will add to give me minus 5 and multiply to give me minus 500. If you find it too difficult to find the factors, you can use the minus b formula. So 500 divided by 25, 20 and 25. Okay, I knew that there must be 5 between them. You can go through the factors of 500. So it's negative, so we've got minus 25 and plus 20. And what we get is that x is either equal to plus 25 or x is equal to minus 20. But what does x mean? X means the number of pupils in the class, and we can't have a negative number of people, so we discard this answer because we can't have minus people. And this is my final answer. Will you lose marks if you don't discard the wrong answer? Yes. Yeah, you can lose up to 3 marks. It would probably just be 1 mark. So, going over that again, we use the information in the question to create equations, use simultaneous equations to cancel one of the unknowns, multiply across by a common denominator, and then solve the quadratic equation. Cancel the answer that doesn't make sense. So there are 25 students normally in the class. Okay, we'll stop there for today, and I will put up some homework in Google Classroom for you to practice with those types of fractions that lead to quadratic equations. Thank you.